So today we're going to talk about arithmetic and geometric sequences. And these two are probably the most common type of sequences that we will be dealing with, and the difference between them. So arithmetic sequences are based on constant addition. So think arithmetic addition. So these two A's, maybe that's going to help you remember that. And then the geometric sequence is based on constant multiplying to get to the next term. So we're first going to look at our arithmetic sequences. So arithmetic addition. Arithmetic sequences, we get this recursive definition. So we would know the first term, then based off of that, we could determine other terms, given that a sub 1, that we would know that term, again, meaning our first term. Then we could find our definition of our next terms based off of that. So two different ways to see the notation to find our arithmetic sequence. Big thing that we want to know here is D. That is your common difference. And it either could be positive or negative. Okay, so we're going to try both of these notations just to see what they look like. And our goal here is we are going to generate the next three terms of the given arithmetic sequences. And again, we have to be told what the first term is, and we know this first term. So for this notation, it's saying I want the next three terms. Okay, so we have our first term is 2. All right, if I'm going to be looking then for our second term, if I were to plug in anywhere I see an n, so maybe I make a notation over here, anywhere I see an n, it's now going to be 2. So in this notation, it says I'm going to take 2 minus 1 plus 6. So if I were to simplify this, f of 2 minus 1, that's really like saying the f of 1 plus 6. Well, we know what f of 1 is. Back up here it was defined. F of 1 is equal to 2. So this is now saying 2 plus 6, which I know is 8. So I could simplify and say I know f of 2 now is going to equal 8. Okay, now we need to find the next term. So in order to find my next term, I have to increase my n value by 1. So again, we know the first term, we found the second term, we're finding our third term. Okay, so I need to find the third term, which means I need to do 3 minus 1 plus 6. Okay, so 3 minus 1 is 2 plus 6. So that's saying the f of 2 plus 6. And remember, we found the f of 2 back here. The f of 2 we know is 8. So I could say this is going to be 8 plus 6, which will now tell me our f of 3 is 14. So our third term in the sequence is a value of 14. Okay, and our last one is, again, increase it by 1. It's going to be n equaling 4. So I'm going to plug into the function. Anywhere I see an n, I make it a 4. So it's saying the f of 4 minus 1, and then add 6. So in other words, it's saying the f of 3, figure out what that was. That was the answer we just found, plus 6. So again, if I look, f of 3 was 14. So I'm going to have 14 plus 6. So now I know the f of 4 is 20. Okay, that was one notation. Let's try the next notation. So this one is saying, again, we know the first term. That's telling us right here. Here's our first term. We have to find the next three terms. I'm just going to separate this maybe so it's easier to see. Okay, so I want to find my second term. That means a sub 2. Okay, according to our definition, a sub 2 is like saying a sub 2 minus 1. So we have to simplify that and then add on 1/2. Okay, so we know a sub 2 minus 1, that's like saying a sub 1 plus 1/2. Well, keep in mind our a sub 1, that was our initial term. Back here, that's 3/2. So now I have something that says 3/2 plus 1/2. So if I have 3/2 plus 1/2, that gets me 4/2, or a value of 2. So now I know a sub 2 is a value of 2. So my second term is 2. So maybe I'll make a list of this over here. A sub 2 equals 2. We have to find a sub 3. Okay, go back into the formula, back up here. So I have a sub 3 minus 1 plus 1 half. Okay, so we simplify this. 3 minus 1 is 2. So that's telling me I'm going to take a sub 2, my second term, plus 1 half. So again, our a sub 2, if I were to find that, we know up there a sub 2 is 2. So now I have 2 plus 1 half. So I could say that's 2 and a half. I could say it's 2.5. I could say it's 5 halves. Any of those is okay. Okay. So then I'm going to make a list again. So a sub 3 now I know is going to be 5 halves. Okay, and I have to find a sub 4, our fourth term. So now I have a sub 4 minus 1, according to the definition, and then add on a half. So 4 minus 1 gets me 3. So I need the third term plus a half. So again, keep in mind, we said our third term, if I look back up here, our third term is 5 halves. So now I have 5 halves plus 1 half for a total of 6 halves, or 3. So I can now say our a sub 4 is equal to 3. So these are our next 3 terms that we were looking for. Okay. So for some number t, the first 3 terms of an arithmetic sequence are defined. It says, what is the numerical value for the fourth term? So the first step we have to do is we have to set up some sort of an equation. And here's another kind of big hint. When you subtract 2 consecutive terms, you will always get the common difference. Okay, so if I subtract 2 consecutive terms, keep in mind these are listed in order. The first term, the second term, the third term. So maybe I take the third term, and I'm going to subtract out the second term. And now keep in mind I'm subtracting everything, so be careful with your signs here. So 6t minus 5t is 1t. 2 minus a negative 1 is plus a positive 1. So 2 plus 1 gets me 3. So what we're finding here is a common difference. Okay. But if I do it again, let's try it again for that second term minus our first term. Okay, so 5t minus 2t, I get 3t. Negative 1 minus 0, I have negative 1. Okay, so they look a little different, but remember what we said. We always want to set up some sort of an equation to solve for t. What we have just found here is our common difference. And these guys are going to be equal. So they're both representing the common difference, even though they're 2 different expressions. But we always know if 2 things are equal, I should be able to set them equal. And then I could solve for t. Remember, if I know what t is, then I can figure out what the terms are. Okay, so I'm going to subtract over t. So now I have 3 is equal to 2t minus 1. I'm going to add over the 1. So I have 4 is equal to 2t. And if I divide through by 2, we now found t is equal to 2. Okay, so this is good because now I should be able to figure out what our common difference was. And remember, both of these back up here represented our common difference. So let's solve for that first. So our common difference, I could plug it into either one. I'm going to just take t plus 3. So t plus 3, I'm going to plug in my 2 that I found. So 2 plus 3, that's going to give me a common difference of 5. Okay. So if I know my common difference is 5, that should kind of help us figure out how I could make my next value. And if I were to solve for each of those that we have up there, I could figure out, so 2t, if I were to plug that in, that would make me 4. And then my next term I had was 5t, so 5 times 2, and then minus 1, so that would get me my next term. Simplifying that, that would get me 10. And if I had 6t plus 2, so that's 12 plus 2, that gets me 14. And I can even check here and I can see, okay, there's a common difference of 5, there's a common difference of 5, and that should then help figure out what our next term is. So our fourth term would be whatever our third term was, and I'd have to add on a common difference of 5. So we already know this third term, we solved that back up there, that's 14, plus my common difference of 5, that's going to get me a total of 19 for my next term using that common difference. So we need to figure out a general term of an arithmetic sequence. And we're going to kind of go through this formula developing process. So we have this formula, and it says our first term is 5. Okay, so we're going to determine the value of 2, 3, and 4. So finding our second term here, we are going to plug this in. And remember, our n value here is 2. So if I'm thinking what's n is 2. So that means I would have 2 minus 1 plus 3. So again, simplifying this, this would say to me a sub 1 plus 3. We know a sub 1 is 5. So if I plug this in, I'd have 5 plus 3, which would get me 8. So I know a sub 2 is 8. Okay. If we do this again for a sub 3, so maybe we can speed this up. So a sub 3 should be a sub 3 minus 1, meaning a sub 2 plus 3. Remember, we just found a sub 2 back here, which was 8. So I have 8 plus 3. That means my a sub 3 is going to be a value of 11. Okay. I need to find a sub 4. So again, take a look at the patterns that we're doing. It looks like we're doing the term before this plus 3. So the term before we found was 11, and if I add 3 more on, I know that a sub 4 is 14. Okay, so how many times was 3 added to 5 in order to produce a sub 4? Okay, so started here with 5, I had to add it on 1, 2, 3 times. So I had to add it on 3 times to get a sub 4. So notice it's 3 times to get a sub 4, which looks like it's almost 1 less than. So it almost looks like it wasn't added, which it wasn't, added to that starting value. Okay, so with that in mind, if we use our results from part B, we should be able to quickly find the value of a sub 50. We wouldn't want to have to go through this 50 times to figure out that number. So keep in mind what we had. It was always that first term, which of value of 5. And to that, we said we had to add on 3, but a total of, well, to get 4, we added on 3 times. It looked like it was 1 less than what we needed. So to get to 50, I'd have to have that 49 times, 1 less than what we need. So a sub 50, quick calculation, I'd get 152. Okay, so if we were to look at this in terms of a formula, to get the term that I want, I need my starting value. So that I'm going to have the term minus 1. It's going to be 1 less than what I need times the common difference. This is a super, super, super important formula that you want to have memorized. Okay, so we are going to take a look then at generating the next 3 terms of this sequence given below. So we have a sub 1 is 6, a sub 4 is 18, and they are all members of an arithmetic sequence. We have to figure out a sub 20. So think about that formula that we had from before. If I know a sub 4, I have to have a sub 1 plus 3 times the difference, 1 less than the term I'm at. So a sub 4 is 18. I know my first term is 6, and now I need 3 times the difference. So I'm solving for that difference to begin with. So if I subtract over 6, I have 12 is equal to 3d. And solving for d, I now find d is equal to 4. Okay, so now I need a sub 20. So I have my first term plus 1 less than the term I need times the difference. A sub 1 being 6 plus 19 times my difference. And that would get me 82. So that's a quick way to figure out a term, especially if it's way far away from the beginning of the sequence. So we're going to move on to our geometric sequences, and they are similar to arithmetic, but the big difference here is a multiplicative constant. So we're multiplying. Okay, we're going to find what's called a common ratio. Arithmetic, we had a common difference. Geometric, we're going to find a common ratio. So generating the next 3 terms of the sequence below, we have a sub 1 is 4, and our common ratio is 2. So if I want to find a sub 2, okay, according to our formulas, I need, think about what this one says over here, I need the term before, right? So we know that right now n is 2, so I would need to have a sub 2 minus 1 times my common ratio. So I need the term before times my common ratio. The term before a sub 1 is 4 times the common ratio of 2. So now I know a sub 2 is 8. Okay, we have to find a sub 3. Keep in mind what we keep saying. I need the term before. So I need a sub 2 times my common ratio. We found a sub 2 is 8. Times the common ratio of 2. So now I know a sub 3 is 16. And so to get a sub 4, it's the same idea. I need the term before times my ratio. So I would have 16 times my ratio of 2. So I get a sub 4 having to be 32. And it's the same with this one. It just looks a little ugly because we have a square root. Works the same way. Okay. So our first term is 3 times the square root of 2. So keep in mind, I now need my second term. So I need to find the term before. So again, I'm thinking to myself, n here is 2. So that would get me 2 minus 1 times the square root of 2. Okay, so that means t sub 2 minus 1, t sub 1. So the term before times the square root of 2. T sub 1 is 3 square roots of 2 times square root of 2. Okay, so square root of 2 times square root of 2 is the square root of 4. And we know the square root of 4 is really 2. So this gets us 3 times 2, or a total of 6. So t sub 2, my second term, is 6. Now we're going to go on to t sub 3. So I need the term before times square root of 2. Term before we found was 6 times the square root of 2. So here's t sub 3. T sub 4. So I need the term before times the square root of 2. So I have 6 square roots of 2 times square roots of 2. And again, square root of 2 times the square root of 2 is the square root of 4, which simplifies to 2. So we have 6 times 2 for a value of 12. So my fourth term is 12. So just like we did before, to determine a formula for an arithmetic sequence, we're going to do the same thing for a geometric sequence based on the first value and common. So based on that common ratio. So for exercise 6, we have consider a sub 1 is 2, and they give us this formula here. All right, so it's saying in order to find my next term, I need the term before times 3. So I have to generate the value of a sub 4. In order to do a sub 4, I need a sub 3. And in order to do a sub 3, I need sub 2, and so on and so on. So in order to get a sub 2, okay, again, that means n is going to be 2. I plug that in and I have the formula 2 minus 1 times 3. So simplify this, 2 minus 1, that's getting me a sub 1 times 3. We know the value of a sub 1 is 2, that was given to us. So I have 2 times 3, and then I know my second term has a value of 6. I want to find my third term. I need the term before, so I need a sub 2 times 3. So a sub 2 we found to be 6 times 3. That's going to get me my third term to be 18. And now a sub 4 is going to be the term before, so a sub 3 times 3. Okay, so I have 18 times 3. So that tells me now my fourth term is 54. So again, how many times did we need to multiply 2 by 3 in order to find a sub 4? Well, we had to multiply 2 by 3. So take a look, 2 is our first term, right? That was our first term here. I had to multiply it 1, 2, 3 times in order to find a sub 4. Okay, so I have to think to myself, 2 times 2 multiplied 3 times to get that a sub 4. And again, the key there, it's 1 less than the term that you're looking for. Okay, so if we were to determine the value of a sub 10, so if I need a sub 10, that means I'm going to multiply my first term by that ratio, but 1 less than. Okay, so think about what we're doing. That's like really a power up there. It's like a power of 9. I'm multiplying it by itself 9 times. Okay, so a sub 1 is 2 times 3 to the 9. We were to plug that in our calculator, huge number, 39,366. That gets you your 10th term. Okay, so let's put this into a formula. So our formula that we have here, in order to find the term, I need to know my first term. I'm going to multiply that times the ratio, but remember, it's going to be 1 less than the term I'm looking for. Okay, and again, big formula that we want to commit to memory. Super helpful once you have that memorized. Okay, bring your questions to class. I know that this is a lot to take in, but we will sort it out in class with some practice. Have a great day.